All right, this is what we need to imitate now. So we have a web server. On this web server, we are going to configure a web application which is internet facing. That application is studentregistration.com. I have the code for that application. I'll share it with all of you, and then we will configure that application, for ourselves. So let me put it on the Google Drive real quick. You all have access to the Google Drive, right?
Yeah.
Yes.
Okay, I'm just putting it on the Google Drive. Just give me 1 minute. I've just uploaded a file with the name testwebsite.html. Can you just download it on your local system real quick, all of you?
Raghu, can you share the link of the drive?
Sure. I've just put the link on the chat window. Just click on this link and you will be able to download this file.
Yeah, got it.
Everyone got it?
No, I'm just logging in. You missed it.
I got it.
What is the file name you shared?
testwebsite.html.
No, I didn't get the Google link.
I've just shared the link, guys, in the chat window. You can directly click on the link and download this file.
Okay. Raghu, can you email me because I'm using my office laptop today, so this is not possible. If you don't mind.
All right, get me your email address, put it on the chat. I've just sent it to you, Dilip.
Thanks, Raghu. I'll download it from there. Thank you.
It is opening some HTML file, right?
Yeah, it's a HTML file.
Hmm.
You can also create web applications in HTML.
Okay.
All right, let me talk about it now.
Okay.
So this is the application. This is the home page of your application. Now imagine yourself as running an educational institution, and you are inviting students to register themselves for the courses that they want to enroll in. So what happens? You basically publish this web application over the internet. Students logs into the web application. They basically type the web application, which is studentregistration.com in their web browser, and they come to this page. And then they type their first name, let's say, then they type their middle name, their last name. They select the course that they want to enroll for example, BCA. They select their gender, phone number, right? They type their phone number, whatever. They provide their address, email address, password, because they're creating the registration on your websites. They provide all of this information and they click on register. This information gets saved in your database, and you know that how many students have registered for which course, and accordingly you will connect with them. So that's the typical sample application that I have, which talks about student registration. Now what we are going to do, we are going to host this application on an Azure virtual machine, and we will make it public. We will publish this application to the internet. So anyone can actually sign into this application, sign into this portal or registration form, and provide the details. That's what we are going to do. Okay. So how do we do this? I would say this basically talks about how do you publish a website over the internet. So this also covers that topic. Now, typically in a production environment, as an Azure administrator, your job is not to publish an application over the internet. Your job is to provide the infrastructure which is needed for publishing an internal or internet facing application. What is that infrastructure? You will provide a virtual machine. If it is a public application, you will provide a public IP so that the name resolution can happen. If that application needs to be highly available, you will put it behind a load balancer. So that's what an Azure admin does. But now we will do both the activities, what an application person does and what an Azure admin does, so that you understand the overall workflow here. Okay, so let's just connect to our first VM. We're going to publish the application on the first VM. So this is my first VM. And let's consider this is a single server deployment, which means all the application components, the web server, the application, as well as the database is stored on the same VM. Okay, so this is my first VM. I'll connect to this VM. I'll just get the public IP and connect to it. Let us all connect to your respective VM. I'm connecting to my first VM. It is trying to reconnect. All right, is my screen visible to everyone?
Yep.
Okay. So I'm connected to my first virtual machine, which is hosting a server operating system. Now, in order to publish an application or publish a website over the internet, I need web services. So I will need to promote this server as a web server. Then only I can publish the application over the internet. That's what you need to understand. Now, how do you promote a server as a web server? A server can be promoted as a DNS server, a DHCP server, a web server, NTP server, Active Directory server. There are multiple roles that you can install on a server, and basis on the role which is installed, a server behaves accordingly. So what I'm going to do, I'm going to add the role of web services on this server so that I can use this server as my web server. So in order to do that, on the server manager, which you get by default, even if server manager is not open, you can just click at the bottom, that Windows logo key, and type server. And you will see the option server manager. Please open it. So this is my server manager. Is everyone on this server manager page? Right, so I'm connected to my first server. I will promote this server as a web server, and then I will deploy my simple website on this server. So how do you do this? You'll go to server manager, then under manage to your right, you see manage. Here, when you click on it, you see a drop down, it says add role and feature. I'll click on add roles and feature. I'll see a pop-up window like this, which says before you begin, I can check the box that says skip this page by default. This is just yarn and nothing. Click on next. It says role-based installation or remote desktop services. I'll say role-based installation, the first option. Then it says, okay, because server manager lets you deploy roles and features to other servers remotely as well. So that's the reason it says which server. So my server is selected. I'll also click on next. And this is the window. These are all the roles which are available in this server. I can select any of those roles and I can promote my server to take off. For example, I can make this server as a DHCP server, DNS server, fax server, network controller, and all. I'll select the role which says web server IIS. This is the role. This is the third from the bottom, web server IIS. Any server which needs to act as a web server needs to have this role installed on it. The moment I'll check this box, it shows me a pop-up. I'll get this pop-up which says, do you want to install management tools also? So I'll say yes, by default, everything is there. I'll just click on add feature. And I will be back on the previous screen, which will say web server is checked. So I'm installing the web server. Then I'll click on next. Now, while you are on the screen at the bottom, where you see this folder icon Explorer, if you can right click on it and open the Explorer for a moment, I want to show you something. So when you go to the Explorer, go to this PC, you see the C drive is here, double click on the C drive and look carefully. Right now you have 1, 2, 3, 4, 5, 6, 7 folders. As soon as you install the web services role on this server, there will be one more folder getting created. And inside that folder, you actually upload your application code. The name of the folder will be inetpub. So we'll keep it open and we'll go back to the previous screen where we need to install the role. So we've selected web server. We'll click on next, 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 and then install. That's it. We'll go with the default settings right now. So it is installing the web server role, or in other words, this server is getting promoted to a web server. You need to perform the same operation on the other virtual machine as well. So let's do multitasking while this role is getting installed. Let's minimize the remote and let's connect to the other virtual machine real quick and perform the same operation there. I'll just copy the public IP. And connect to the other virtual machine. Somehow I'm not able to connect to my other virtual machine. It is saying that the password is wrong. So I'll quickly change the password, reset the password. I'm resetting the password real quick.
Was there any other features that needed to be installed or just the role?
I'm sorry, Henry, can you repeat that?
Were there any other features that needed to be installed or just the role?
Just the role.
Okay.
All right, so while the password for the other virtual machine is getting reset, let's connect to the server. And the installation succeeded. It says feature installation succeeded. And I'll click on close. When I click on close, if I go back to my Explorer, I will see that a folder is getting created for today's date at this time with the name inetpub. Now, this is the folder. Any website that you see over the internet is actually hosted on a web server. It could be a Windows-based IIS web server or a Apache Tomcat, but the code of that website will be inside this folder. So now my server is promoted to a web server. I can also validate it. How I validate it? I'll open the Internet Explorer on this server. Any browser, I will say by default it has Internet Explorer. And on the Internet Explorer, I'll just type localhost and hit enter. When I type localhost and hit enter, it says Internet Information Services. This validates that this server is a web server because it is giving me the page for IIS in short. So IIS is the web services that needs to be installed. Now, this is something, as I said, an Azure administrator does not do. This is the work of application team. So this proves that my server is a web server now. Now I'm going to upload my website on this server. Okay. So how I do it? I'll close the server. I'll go to the Explorer. This inet puff folder that you see. You go inside this folder, and then inside this folder, you have another folder that says www root. Now, this is the folder where you actually keep the home page of your website. So you go inside the folder. Inside this folder, you see these two files, IIS start. Just delete these two files. We don't need it. Now the folder is empty. Now in this folder, please copy the test HTML page, the website code. So I'll quickly copy it. I'll just copy it. So I'm copying it.
So Raghu, that was my question. So we'll just simply do Control-C, Control-V while copying it to here.
Yeah, that's exactly what I did. C Control V. From my local system, my website is here. Test website page is here. However, there is one more step that I need to do. First, I will need to change its name. The home page of any website, the name should be index. So I'll put the name as index. That's the first thing that I did. I changed the name of the website. Okay. Now, this is changed. I'll just minimize it. And once again, open Internet Explorer and type localhost. And you will see that your website is locally hosted on this server. See, it's hosted. So this is how you host a website. You have the website code. You will just put that code file into the www root folder, and you change the file name as index, and that's exactly what you see locally. So this server is now hosting student registration portal or student registration form. Let me know if everyone is able to do this.
Yes.
Yeah, no worries.
Okay. Now, at the same time, this server also has a public IP, so we can act. So this website is also available on the public internet. How do you validate it? Just copy the public IP of this server and put it on local browser. And not inside the virtual machine, but on your local system. Just put the IP and your website should be up and running. So this is my first web server. I'll just get the public IP of it. Okay, and I'll put the public IP into the browser tab and hit enter. And I should get my website, shown here. All right, it's loading. All right, so when you type the public IP, typically you type the domain name, which is studentregistration.com, which resolves with the public IP, and the traffic and the request goes to the server, which is hosting that public IP. Since we do not have a domain name, we'll just use the public IP. However, it says this cannot be reached. There is something that we are missing, guys. Let me know what we could be missing. It is related to networking.
The NSG rule.
Great. I'm glad that you brought this up, Henry. This is exactly what we are missing.
Yeah.
We are sending traffic from the internet to this server on port 80, and port 80 is not allowed on the VM. So we'll go to the networking tab of the VM and we'll add one rule for port 80. So we'll click on add inbound rule and we'll say source could be any, port could be any, destination any. And now we will select either in the custom, we can select HTTP. The moment you select HTTP, the port will be displayed because everybody knows that HTTP means port 80, and then we'll just add it. That's it. So we need to add a rule on the VM NSG that if the traffic arrives at port 80, please accept it. Now that rule is created for port 80. if I just go to this browser tab and refresh it, you will see my website. Just give it some time. I'm safe. Yep, here we go. My website is up and running. I'll give you the public IP address of my VM. You can also try it on your system. You all will be able to browse my website using this URL. And same is the case with you guys. Your website is also up and running, and it is available across the globe. People from anywhere in the world can actually browse our websites now. You can try. I've just pasted in the chat window. Just click on this and you will see my website. Let me know if this works.
Working on both. Yep.
Right, so it's
Yes, it's working for me.
Okay, but now our websites are same. I'm so we all are using the same HTML code, or we are using the same web application. Let's do some differentiation so that we can recognize our own. Okay, let's go back to this. So this is how you make modifications to a website. So we'll go back to our virtual machine. This is our virtual machine, and this is my website code. I'll just right click on it and open with a notepad because I need to edit it. So I can open it with a notepad, and this is the code. And what I can do, I'll just make a small modification. So this is the entire code of the website. This is HTML code. I'll come to this line which says student registration form. This is the heading, H1 heading. And I'll just put my name here. Or the VM name, whatever. So I'm just changing the heading. I'm just putting my name and my VM name, and then I'll save it. That's it. So that way I can recognize, I can differentiate my websites from you. I've just saved it. I'll go back to the internet. I'm say on my local system browser and refresh it, and you will see. This is really quick. You're making the changes on the website and it is reflecting to rest of the world. You can also refresh your browser for my website and you will see this change now. Did you double check? Is it working for you?
All good.
Great.
Yes.
Can I get the IP? Can I get the URL for your respective websites, guys? Just drop it on the chat window. Let me double check if it is working for me. As if I'm able to browse your websites. Henry, can you put your website?
Yep, just getting the data now. Where's it?
I got for Henry. Henry, I'm trying. Yep, it's working. On the second, great, it's working. Nice, great, great. Now,
Raghu,
yeah.
Raghu, sorry. So Raghu, I did that, change for allowing internet. And after that, I was trying to open this website in the using public IP, but I'm getting timeout error. Is it because maybe Office laptop or something like that?
No, it has nothing to do with Office. If it was working before, it should work now.
It is working in the VM. Okay, I'm able to open that website in the VM.
Why don't you give me your website IP address? I say I'll try it on my system, and that will clarify if it is because of Office system or something else.
Yes. 1 second. Yeah. I'll just give you.
Okay, so Prateek, website is also working. AZ104 student registration system.
Raghu, I have given my IP address also.
Prateek, it's working. Dinesh.
Yeah. So Raghu, can you check
Dinesh
mine?
is also working. This is mine. Delete. Okay.
Yeah, I've just given mine now.
So this is for delete. Let's see. Yours is not working, delete here.
Yeah. So where?
Something to do with NSG rule.
Dilip, did you add that port 80 for the inbound rule?
Yes, I added. Let me check it again.
I'm not able to open it. Can others try for the Delete website? See if you're able to open his website on your system.
No, same issue.
Okay, Delete, this is something to do with traffic.
Yeah.
We are not able to send traffic to your web server using this IP.
Okay, I'll check. So it should.
So while we're checking the lead, you know, let's talk about.
I got it. Yeah.
Okay. So let's imagine, guys. You know, we had this web application up and running, and you know, as I said, we own an educational institution. We provide a couple of courses to students. Student register for those courses on our website, and then we provide them. We actually provide them online classes. That's the business that we are in. We started our business with one web server, and very soon it became very popular. And now we are getting, and now since this web server is hosted in Azure, one day my machine went down. My virtual machine, my web server hosting this website went down, and my website was not available. I got a couple of complaints from users that they were not able to browse the website, and they were just not able to register for the course. So that's the scenario. I mean, so when you have one server hosting your business critical website, and if that server goes down, your application goes down, your business is impacted. So for any business critical application, what we do, we at least have two instances of the same role, right? And we load balance the traffic. When we have two, then we will also put a load balancer at the front so that we are load balancing the traffic. Now let's go back to the lab whiteboard. And if you see here, this is the current scenario. So let's just imagine, we have done the DNS mapping. So student registration form, this user type student registration form, the traffic over the internet reaches to the web server, and the user is able to browse the website. But due to some XYZ reason, this VM goes down. When this VM is not available, some issues with this VM, what happens? What this user will get? This user will get an error that page cannot be displayed, page not found, something like that. Am I correct? Am I correct?
Yes. Absolutely.
Okay.
Yeah, sure.
That's what the user will get. Now, as the owner of this website, I want my website to be highly available. So in order to make it highly available, what I do, I will add another VM to the stack. I will add another server to the stack, which will host the website. Now, when I add another VM to the stack, which is also hosting the website, how will I load balance the traffic? Because when the user types studentregistration.com, right, because the other VM has a different public IP, so we need to load balance the traffic. So in order to load balance the traffic, what I do typically, what people will do, they'll put a load balancer at the front. So what will happen? The traffic will go to the load balancer. This is the scenario now. So traffic will go to the load balancer when the student registration, when the user types studentregistration.com, this resolves with a public IP address, which you configure at the load balancer. The load balancer receives that traffic. It will forward that traffic to one of the web server. And that's how your website is highly available and also providing good performance, is getting load balanced and highly available. Is that understood, guys? This concept of load balancing?
Yep.
Okay. Now this is exactly what we are going to do. So first of all, we need to have our website up and running on both the VMs. The reason I did this change and put my name and VM name, so that once we do load balancing, we also need to validate it, whether or not it is happening. So that's the reason we are actually putting the VM name in the, in the website somewhere on the heading. So once we do the load balancing, we will actually validate if that load balancing is happening or not. I'll share my website address with you. One of you will get the response from the first VM, the other will get a response from the other VM, which proves that the load balancing is happening. Users are the load balancer is actually distributing the traffic equally to the web servers, which are there in the backend pool. So that's what we are going to do. For this, let's have our website up and running on both the servers first. My website is up and running on my first server, but for the second server, it is still not there. I'll quickly do it on the second server. And Dilip, I hope you were able to resolve the issue with the connectivity. The first VM.
Actually, instead of setting this internet rule at VM level, I think I set the rule on subnet level actually. So that was the issue. I clarified it. Now I will never forget that.
Okay, and that's where the complexity lies. You have your VM has two NSGs, one at the subnet level, one at the VM level, which is creating the complexity. Why don't you delete the NSG which is at the VM DIC level, so that that complexity is gone? Or you delete the I see, you cannot delete the NSG which is at the subnet level, but you can delete the NSG which is at the VM level. That way you don't have to manage NSG rules at both ways.
Yes, I'll do that.
This is making your life difficult. Let's just simplify it.
I'll do that. That's fine, but I mean, at least I came to know like the kind of security we have.
Great. So I'll connect to my other VM real quick. It will take me, 2-3 minutes to configure the other website. No, almost 5 minutes, because I also need to install the web services role, which will take time. So meanwhile, you can also do this, guys, for your other VM real quick while I do it for my VM. Then we'll talk about load balancing. And while I'm connecting to my VM, okay, I'll do some multitasking. I'll also add an inbound rule real quick. Now, guys, this is the another thing that you can do. If you don't want to create multiple rules, you can whitelist multiple ports in the same rule. For example, this NSG rule, which is for RDP, I can just click on this rule and I can put. Now, since I've selected the service as RDP, I won't be able to do it. So instead of service, I'll put custom. I'm just giving you another option. And now I'll put 1 comma and put port 80 as well, and just save it. So I can also do it this way. I can have one NSG with multiple ports whitelisted. So I've just saved some time of creating an NSG. Now I'll go to my VM. Okay, I'll quickly go to add role and feature. Henry, you've done it on both the VMs, right?
Yeah, that's right. I thought that's what we were doing before. That's okay.
Yep, that's great. So I select, where is my web server? Web server. Next, install. Great. Oh, I will need to wait once it gets completed, because unless and until it is not completed, I won't be able to actually see this inetpub folder in the C drive. Meanwhile, I'll copy my website, test website. Copy. And I'll wait for the role to complete.
So Raghu, while you do this, I have already done this. Like my now website is in both the VMs and I can access both the websites from my internet.
Great. Have you put some differentiation in both the website code so that you can recognize that
Yes,
this?
yes. Yeah, I have put my name in first website and second one is by default. Like,
Okay, that's okay. Great. Let's hit complete. So other than Azure, you also learned today how to host a website, guys.
yeah. So Raghu, my question was like, we just copied this simple HTTP file, which is less in size, like 10 MB, whatever. But suppose we are copying the software setups because let's say which is in GB. Suppose I want to install a software on my virtual machine, which for which the setup file is in GB. So can we just do the copy paste, or is there any other file FTP we have to do?
No, you will not do copy paste. In that case, you will use FTP.
Okay.
Or you will use another service from Azure, which I'll talk about, Storage Explorer, through which you can copy data from your on-premises system to, so we basically do FTP in the case wherein we don't have access to the underlying infrastructure. If you, for example, you purchase hosting services from GoDaddy. Now you purchase a plan, GoDaddy, according to that plan, GoDaddy will, configure a server for you, but GoDaddy will not give you access of that server. You need to upload your website, then you will use FTP solution like WinSCP or FileZilla to actually upload the code of your website to that server. But in this case, since this is a virtual machine that we own, we can directly go to the virtual machine and we know where exactly that code is going. So this site is up and running. So I've just installed it. I'll go to inetpub real quick. I'll go to www root, delete the existing 2 files. They are not needed. Copy my sample HTML. I'll right click on it, change the name. The name has to be indexed. If you change the name, the website will not work. Homepage name should always be indexed. Okay. Then I'll right click on it and open with Notepad. I'll go to registration form and put my name there. Done. I'll save it. Great. I'll just copy the public IP once again for this VM. Put it on the browser. And there we go. There we go, my website. So my website is also up and running, my second website. Now we'll talk about the load balancing part. Let's talk about the load balancing part, guys, which will take another 20 minutes. So you want to take lunch break now, or we want to complete this exercise, then take the lunch break?
I'm happy to complete.
Okay, let's complete. So let's wait for another 20-30 minutes while we do the load balancing part. Okay. Let's do a quick theory of load balancing. Let's quickly do that. All right. Load balancing. You already know what a load balancing service is. What is the significance of load balancing? Let's understand what services are available in Azure platform for the purpose of load balancing. So Azure has a service with the name Azure Load Balancer. Azure Load Balancer, we primarily use to evenly distribute or equally distributing incoming network traffic across a group of backend servers. So in Azure terminology, servers, these web servers which are running behind the load balancer, they are known as backend servers, and this is known as backend pool. So in the load balancing language, we say that, okay, how many servers do you have in the backend pool of a load balancer? We can see 3 servers are there. So an Azure load balancer operates at OSI layer 4. transport layer. That is the reason we are putting port, TCP/IP port for the in the NSG for the for the white port, for the whitelisting. So Azure Load Balancer actually operates at OSI layer 4, which is the transport layer. There are two types of load balancer in Azure. You have a public load balancer. That is what we are going to create today. The public load balancer will distribute incoming traffic from the internet to the virtual machines in its backend pool. Then there's an internal load balancer, which will distribute internal traffic to the backend machines, which is this. It's similar. There is absolutely no difference in provisioning. So you can see it here. Here's the example of public and private. So this is my public load balancer, because this load balancer is receiving traffic, incoming traffic from the internet, and evenly distributing that traffic to one of the web servers. Then imagine that my website is 3-tier application, and I also have an app tier and database tier. So for the app tier, I also have a load balancer, which will receive traffic from one of the web servers and evenly distribute it to the application servers. Then there's a load balancer at database layer, or the DB layer, which will receive traffic from one of the app servers and distribute it to one of the web servers. So these are the internal load balancers, these two load balancers, and this load balancer is public load balancer or external load balancer, whatever your terminology you are comfortable with. If you look at the difference, the public load balancer has a public IP, but these internal load balancers, they will get a private IP from the subnet that they are hosted in. So if you look carefully, this load balancer, public is outside of the virtual network. This is not inside the virtual network. But these two load balancers, internal, they are inside the virtual network, and they are contained within the subnet that they are load balancing traffic for. So which means these load balancers will get a private IP. That is the reason we call them internal load balancer. The functionality remains the same. Only the role changes. If you allocate a public IP, it becomes a public load balancer. If you allocate a private IP, it becomes an internal load balancer. So that's how load balancing happens in Azure. So public load balancer, it maps public IP addresses and port number of incoming traffic to virtual machines private IP address and port number, and it applies. So load balancing happens. The algorithm that they uses is round robin algorithm. Round robin means distribute the traffic equally to all the servers. This is my public load balancer, the first image, wherein you see that the traffic is coming from the internet on port 80. It reaches to the load balancer. Load balancer distributes that traffic equally to all the VMs. So that's my public load balancer. In the web tier, which is what we have in this case, then there is another load balancer, which is my internal load balancer, which is at the database layer. And this is receiving traffic from one of these three servers. They could be web servers or app servers. And then it distributes that traffic to one of the database servers. That's my internal load balancer. Any question on this slide? Okay. Great, let's move on. I'll share the slide deck today with you guys, because we will be completing majority of these slides today. Then comes the load balancer STU. Now load balancer comes in two varieties, basic and standard. As you have already seen so far, that most of the Azure services has some varieties. And depending on the variety that you pick and choose, you get certain benefits, certain additional capabilities. So if you take a basic load balancer, it supports up to 300 instances, which means basic load balancer in its backend pool will have up to 300 VMs. But a standard has 1,000. The other benefit of standard load balancer is that it supports SSL, which is secure communication. If you want to secure your web application by putting an SSL certificate on it, HTTPS port 443, you should be using standard load balancer, because basic load balancer doesn't support HTTPS. The other benefit is that the basic load balancer is free of cost. There is no charge for it, but it is used for non-production scenarios. The standard load balancer has some price tag associated with it, but it provides you benefits like secure socket communication, secure communication. It also has an SLA. Since you're paying to Microsoft gives you an SLA. Microsoft says that you will have this load balancer available 99.99% of the time. And if this availability goes below, we will give you compensation. So that's the benefit of, that's the comparison between basic and standard. Now, what are various load balancing services available in Azure? So these are the 4 services which are available in Azure. We have 2 load balancer services which are at global load balancing. Basically, global means you can use these services to load balance an application which is deployed across multiple geographies. And then we have 2 load balancing services which are regional, which can only load balance the traffic to a regional infrastructure of an application. So we have application gateway, which is a layer 7 load balancer. For example, this Azure load balancer that I was talking about, it works at layer 4. An application gateway works at layer 7, which is application layer. In other means, it also means that application gateway provides you additional capabilities, so it can protect your application from attacks which happens at application layer, which are SQL injection, cross-site scripting. It also includes a web application firewall. So it has WAF capabilities included. So this is an advanced load balancer. For this lab, we'll focus on Azure load balancer. So you have some slides on application gateway. You can go through it. You can try and configure application gateway by yourself. And if you face any issue, just let me know. I'll help you. Let's do the configuration on Azure portal. Theory you can get from Azure documentation. I'll share the slide deck with you. So, and you already have Azure book with you that you can read for theoretical aspect. Let's do the load balancing in Azure portal. So let's log into our Azure portal, everyone. On the Azure portal, we will type load balancer. I'll type load and I'll see the option load balancers. Now, earlier what Azure would do, Azure would have separate UI, user interface, for all the load balancing services. But now Azure has merged them all together in one UI so that customers can get all the options here. So we have application gateway, front door, load balancer, and traffic manager. We are going to focus on load balancer. So we will click on load balancer. Now, before you provision a load balancer, let's understand some terminologies of load balancer. A load balancer has a front-end IP address, which is the IP address that you associate to the load balancer. It has a backend pool. Backend pool basically means where the virtual machines are kept, virtual machines are added.
Yeah.
It also uses health probe. Health probe basically means that these virtual machines, because load balancing will happen on some port, like port 80 or 443. So health probe basically means what load balancer will do if load balancer has 2 virtual machines in its backend pool, or let's say 10 virtual machines. It will continuously to send a small traffic, a health probe, on the specific port on which it is load balancing to those virtual machines. If a virtual machine does not respond to a probe, let's say twice, consecutively 2 times, it will consider that virtual machine as unhealthy and it will stop sending traffic to that virtual machine. When a virtual machine stops responding to health probe, when it is unavailable, let's say you have 10 virtual machines behind the load balancer, one of the virtual machine you just turned it off or is unavailable because of some issues. So load balancer is intelligent. It will not send traffic to that virtual machine which is unhealthy, because if it does so, what user will receive as a response? Page cannot be displayed because that machine is not available. So load balancer does health probe. Then comes load balancing rules. Load balancing rules basically says that on what port load balancer will receive traffic and then on which port it will forward the traffic. That is known as load balancing rules. So these are the 4 configuration items that we will do while we configure a load balancer. Now, Microsoft has made it a bit complicated. Earlier, what would happen when you create a load balancer? In the load balancer view, you will configure these options one after another. But now Microsoft has made your life a bit complicated. by giving you the entire configuration during the load balancer provisioning. For example, when you provision a virtual machine, you have 6 tabs and you will pick and choose services from those tabs. And then you finally click on review and create. Similarly, now when we are going to create this load balancer, we will see all of these options and we will configure it during the load balancer creation itself. So let's do it. So we'll click on create load balancer. Okay. Now, you need to follow these steps with me. If you lag behind, then you will not be able to do it. So stop me if you feel that you're not able to configure or you're not able to follow me. So it starts with basic tab. Now the basic tab, you need to select the resource group. So you selected the resource group. Then you need to select the name. So I can say this is my sample LB. Then you need to select the region. Definitely it has to be East US. If I select West US, this load balancer will be of no use for me because for West US load balancer, I cannot load balance an East US virtual machine. So I will select the same region. This is where I make a decision. If this is an internal load balancer or public load balancer. Let's say if I say internal, the moment I say internal, the moment I say internal load balancer, on the next screen, it will ask me on the front end IP configuration, it will ask me to choose the virtual network in subnet. See, subnet and virtual network, because I will need to provision this load balancer internally. But if I go back to the basic tab and if I select public, and when I go to the front end configuration, front end IP configurations field and click on add a front end IP, it has asked me to take a public IP. That's the difference in internal and public. So I'll provision a public load balancer. Then it says SQ of the load balancer. Now this is very important thing. If your virtual machine has a public IP on it, and if the SQ of that public IP is basic, then you cannot use a standard SQ load balancer to load balance that virtual machine. Azure follows the principle of compatibility. The SKUs should be common across all the services, right? So if I take a standard SQ load balancer, and if my virtual machines are using public IP, which are basic SKU, I will not be able to add those virtual machines in the backend pool of this load balancer. So you need to be careful of this. Since we are doing this lab exercise, and I already know that my virtual machine is using a basic, IP address, basic public IP, I'll select basic load balancer. I'm also selecting basic because it is a free service. If I select standard, I will end up paying for it. So I'm selecting basic. The moment I select basic, see, it already has the tier as regional, because your load balancer, be it public or internal, it is a regional service. That's what I've just shown you in this slide. So it's a regional. So I'll select public and I'll select basic. So once again, I'll select my resource group, select the name of the load balancer, region, the type is public, and the SQ is basic. I'll move on to the next tab. In this next step, I will need to add a front-end IP to the load balancer, which is a public IP. So I'll click on add a front-end IP. Now, when I click on add a front-end IP, I see this pop up. There are two options. If I have an existing public IP, I can allocate it right now. If not, then I can create a new public IP on the screen itself. So I will give the public IP name, which is, now I'll use the consistency naming here. I will use my load balancer name everywhere. And so this is my load balancer sample LB. And for the front end IP, I can use it FIP, which stands for front end IP. And now I need an IP address. So it says can be associated. I do not have any IP address, public IP address, which is available. So I'll quickly create a new one. I'll click on create new, which will open another drop down, and I'll put the IP address name. Since this IP address is going to be allocated to my load balancer, I'll use the same nomenclature, which is sample LB, and I'll put it like sample LB PIP or sample LB front-end IP, FT front-end FDP IP, whatever name I want. And I click on OK. So I've just selected the name of the front-end IP address. I'm saying this is the name of the front-end IP configuration, and this is my front-end public IP address. I'll click on Add. So my first tab is completed. I've just added a front-end IP address. Is everyone through with this step?
Yes.
Raghu, if you can just show
Yep.
the IP address again.
This is the name of the front end, and then I've just added the public IP. You want me to do this all over again?
Yes, please.
Okay.
Just please show that basic one as well, the tab. Let me just double check. Public. Correct. Please
Okay.
move it.
I'll go to the front end IP tab, and I'm doing it all over again, guys. Please look at carefully. I'll put the front end IP name. I'll put my load balancer name just to recognize an FIP, which stands for front end IP. This is the name. You can take any name. Then I need a public IP address for this load balancer. I don't have an existing IP, so I'll create a new IP real quick. And I've added the front end IP, and I'll click on Add. So that's the first step. I've just added a front end IP configuration for my load balancer. Is it done, Dilip? Can I move on to the next step?
Yes, we can. Yeah, I'm done.
Next is backend pools. Now in this, I will need to create a backend pool and then add the virtual machines which I want to, put behind this load balancer, so that load balancer can load balance the traffic for those virtual machines. So first of all, I'll create a backend pool plus add a backend pool here. It says backend pool name. I'll follow the same pattern, which is my load balancer name. And for backend pool, I can use BCKT, which is backend pool in short. So I've selected the name. Then it says select the network where your virtual machines are. So I select my network. Then it says, okay, what do you want to associate? Virtual machines. I'll select my virtual machines and then IPv4. Then in the virtual machines here, I'll need to click on add. When I click on add, it will populate all the virtual machines which are part of this virtual network. So I'll click on add. The moment I click on add, you see both the virtual machines are visible. They are populated. I'll select both the virtual machines and I'll click on add so that they start to reflect here. So I have just created the name of the backend pool, selected the network, selected and selected that I want to associate virtual machines, then selected both the virtual machines.
Here is the glitch, Raghu. Like when we have two, I have two virtual networks, and when I select them, I don't see any virtual machines in that. So
you need to select the virtual network that has those two web servers which you just promoted. Those two virtual machines which you promoted to web services role and you install your website. You need to select the virtual network which comprises those two virtual machines.
okay, I'll do it again. Yeah.
What about others? Are others able to follow this?
Yes, Raghu.
Okay, Henry, is it working for you? Were you able to select your
Yeah.
virtual machine?
Yeah, all good.
Okay. Philip, let's quickly do that.
Yes, I'm doing that. Give me a second. Just a second. Sure.
Is it completed, Dilip?
No, Raghu. Just give me time. Like I'm not getting that. Unfortunately, so
No worries. Others will help you. Let this complete, then others will help you.
Okay.
There is something which you're not doing well.
Sure, sure. I'll just watch and then we can do it.
Please. Sure. So we are done with this. Now I'll click on add at the bottom. So my backend pool is also added. So I'm done with front-end IP configuration. I'm done with backend pool also. Now I'll go to the next, which is inbound rules, which is the load balancing rule, the next option. So I'll click on add a load balancing rule on the next tab. And here I need to actually define the traffic type, that on which port the traffic will come, and then on which port it will be forwarded to. So I'll put the load balancing rule name as same my load balancer name, sample LB hyphen LBR. In short, load balancing rule. You can choose any name that you want. IPv4. Then you need to select which is the front-end IP address on which the traffic will arrive first. So you will select your front-end IP address, and if you look carefully, it says in bracket to be created, because you have created this you have given configuration for this front-end IP address in the first step after basic. So you will select your front-end IP address. Okay. Then you will select the port on which the traffic will arrive. Since we are not using SSL, we'll select port 80, which is the default HTTP port. Then it says backend port. So the traffic will arrive on port 80, but do you want to send the traffic on any other port in the backend pool? This option is also available. I'll say that no, I want to send it to the same port 80. So traffic will arrive on port 80 and my VMs are also listening on port 80. Then it says, okay, now select the backend pool, which pool the traffic will be sent to in the backend. So you select your backend pool also, which you have given information in the previous tab. Then it says health probe. So since you are configuring the load balancing rule at port 80, you can configure it on multiple ports later on as well. Once the load balancer is configured, you can modify the configuration. So we'll select the health probe. Now, since we don't have a health probe, we'll create new in this window itself. So we'll put the health probe name and follow the same nomenclature, sample LP and HLP for health probe. Then I'll select the protocol, TCP. By default, it says 80. And then the interval. This interval says that what is the amount of time between different health probes. So it basically means that the load balancer will send health probe every 5 seconds. Unhealthy threshold means that if a virtual machine do not respond to a health probe twice, which is in a 10 seconds interval, because every 5 seconds it sends the probe. If the virtual machine does not respond once, okay, twice, okay. If the virtual machine doesn't respond twice, it will consider that virtual machine as not healthy or unhealthy, and it will stop sending traffic to that virtual machine. That's the health probe. So I've configured the health probe also. Then it says session persistence. What is session persistence? Session persistence basically means that if you want the traffic from a specific user to be sent to a specific web server all the time, then you can enable session persistence. So example, if you have 2 web servers in the backend pool, and there is this user who is connecting to your website from the same public IP all the time, then the traffic of that user will be sent to a specific web server only. That's session persistence is. But the challenge is, if you enable the service, it diminishes the purpose of load balancing. What if that web server is unavailable? That user will not get the response from the website, right? So by default, we don't enable session persistence. But if you feel that you have a use case for it, your application actually requires users, to be connecting to the same web server all the time, then you can enable it. But I'm not enabling it. If you want to read it, you can click on it and it shows you whatever I've just told you. Then comes floating IP. By default, it is disabled. It has the same concept. Floating IP, what it does, it basically your traditional load balancing. So it also diminishes the purpose of traditional load balancing because it keeps on changing the IP address, which is not recommended. So we are not doing it. Why these options are available? For a specific use case if you have. Then it says ideal timeout, which is 4 minutes, which is the minimum. So 4 minutes basically means if somebody tries to connect to my website, which is getting load balance using this load balancer, that request will remain alive, TTL. It also means TTL, time to live. That request will remain alive for 4 minutes. After 4 minutes, user will get page cannot be displayed. So that's the load balancing rule. I'll click on add. Is everyone with me on the load balancing rule?
Yep.
Okay, great. Then comes the outbound rule. We will not configure anything on the outbound rule because we are using this load balancer for the incoming load balancing, not for the outbound. So we'll leave it blank. Then next tag, you want to put it. Otherwise, click on next, which is review plus create. It will review all the settings that you have just provided. Okay, the validation passed. Now you will hit create. So now this is creating the load balancer, and along with the load balancer, it is creating a front-end IP, it is creating back-end pools, inbound rules, and all the configuration. So in one window, you can provision the entire configuration. Earlier, you would only provision the load balancer, then you will provision the front end. After front end, you will provision the back-end pool, then you will provision the health probe, then you will provision the load balancing rule. So Microsoft has changed that experience. So our load balancer is getting created. Now, as soon as this load balancer is created, my website will be available from this load balancer, which means I can actually remove the public IPs from my web servers, because now I don't want people to directly connect to my web servers. I want the entire traffic to actually go via this load balancer. And how I can do it? Whatever is the load balancer public IP, I'll just map it with the website domain name. So if my website domain is studentregistration.com, and if I have purchased it from GoDaddy, I'll just log into my GoDaddy website. I'll go to the DNS and I'll create a record, a text record, and against my domain name, I'll put my load balancer public IP. So that whosoever types studentregistration.com in her web browser, it resolves to this load balancer public IP. Load balancer receives the traffic. It knows that there are two servers in my backend pool. It will forward that traffic to one of those two web servers. That's the overall flow of traffic. So the load balancer is done. It's created. I can click on go to resource. And when I click on my load balancer, let's look here, settings. See, this is how it would happen in the past. You will create a load balancer, then you will create a front-end IP address, then you go to backend pools, health probe, load balancing rules in sequence. But we have done everything in one go. So you can quickly validate. This is my front-end IP address. This is the IP address for my load balancer. I can just copy this IP address and I can put it into the browser and hit enter. Here we go. My website is getting load balanced now. I've got the response. This time the response is coming from my web server, first web server. Now I'll give you this public IP, guys. I want you, all of you, to actually put this public IP in your respective web browser and tell me which server you are receiving response from. Some of you will receive response from web server 1. Some of you will receive response from web server 2, which will validate that the load balancing is happening.
Yeah, I got you on 2.
I got on 2. Yeah.
Great.
Yeah, myself on 2.
Okay.
I got on 1.
Yeah. So which proves that load balancing is happening. Some are receiving response from web server 2, some are receiving response from web server 1. And that was the ultimate goal of changing this, making this modification to the code so that we can actually validate that the load balancing is happening. Now, if you shut down one of your virtual machine, let's say I have 2 virtual machines in the backend pool of the load balancer. If I just shut down my first virtual machine for a moment, I'm just assuming that this is unhealthy, just to make it unhealthy. So I'm just shutting down. Now what will happen? Every 5 seconds, load balancer is sending a health probe on both the virtual machines. This first virtual machine, first web server will not respond to the health probe since it is not available. 5 seconds later, when it sends the another health probe, it will not respond. Load balancer will consider it unhealthy and load balancer will stop sending traffic to the server, which means if you just refresh your browser window, all of you will receive the response from Web 2 now. So the people who were receiving response from Web 1, let's refresh your browser window and you will see that now the response will only come from the first, the response will only come from the second server.
Yes, that's what I got.
Yep. So this proves that the load balancing is happening, right? If I just put it again and see, I'm now getting the response from the 1. I'll just refresh. Now I'm getting the response from 2. And if I continue to refresh the page, it will continue to remain 2 only because 1 is not healthy. So I'll go to the load balancer. I'll show you how to check it. So I'll go back to the load balancer here. And on the load balancer view, I'll see some analysis, some real-time matrices with respect to the monitoring also. So I can configure alert. I can, there are multiple options which are available to me that I can configure at the load balancer layer. Now, if you want a DNS, as I said, if you have a domain name, you can quickly do that. Otherwise, instead of typing the public IP, you can also type this name, sample LB FTD IP. This will also work equally because that's the name of the public IP. No, I'm sorry. You need to put the DNS. I'm sorry. So if you want, you can also configure the DNS for this load balancer. And how do you configure the DNS? You need to go to the your DNS registrar and it will work there. So that's the another option that you can do. So for example, this is my public IP.
You can't put the DNS name on the public IP like you can for a virtual machine.
Yeah, this option is not available. I mean, that's the reason I said this option used to be available. Azure is very earlier. This option was available. Maybe with basic it is not available. If I just upgrade my load balancer to standard SKU, then I'll see that option public, DNS. Then I can quickly, create a DNS and I can, resolve my public IP with that DNS. So that could be the reason because I'm not able to see it today. So they've removed it from public now. So this is how we are doing load balancing, guys. That's all about load balancing.